In this video, we're going to learn about the intersection of intervals. So the first question here is, given the inequalities x is greater than or equal to 1 and x is less than 3, express their intersection using interval notation. First of all, what does intersection mean in this context? Well, in this context, intersection means the common set of values. Now, when you see the word intersection, you might think of two curves on a graph and the intersection of being where they cross on the graph. And really, this is just the same idea here, just in the context of single variable inequalities. When two curves intersect on a graph, that's where they share the same point, meaning that they have the same value at that point. And here it's the same idea. Our intersection is just the common set of values for x in both of these inequalities. It's just going to be where these two graphs overlap. And so in order to find that overlap, we're going to have to actually graph these, and then we can see where it overlaps. So first of all, x is greater than or equal to 1. So we're starting at 1 here. We'll put a dot there. That's filled in because we could have x be equal to 1. And then x is greater than or equal to 1. So we're going to the right towards bigger numbers. So let's shade in towards the right here. And the other inequality, x is less than 3, that starts at 3, but we have an open circle because x cannot be equal to 3, can only be less than 3. And now let's shade everything to the left because we're going less than 3, so to numbers that are smaller than 3 and more negative than 3. So we'll shade over this way, put an arrow on that, and there we have it. Okay, so we're looking for the common set of values between these two graphs. In other words, we're looking for the overlap between these two graphs, and we see that the overlap is right over here. The overlap starts at 1 is included in that overlap, and then it goes to the right. We've got red and blue intermixing here, and then all the way up until 3, and then 3 is where blue stops appearing, an open circle, because 3 is not included, so the overlap has an open circle at 3. Okay, so now we have the overlap, we have the intersection that's right here, and we just need to write that using interval notation. Before we do that though, why don't we go ahead and write it using inequality notation, like we were given in the problem statement. So we'll just say x is between two things. First of all, it's got to be greater than or equal to 1. So x is greater than or equal to 1, that's on the left. Then we're going right, and then we're stopping at 3, and x has to be less than 3, not equal to 3, because that's an open circle. So there's our inequality that represents the intersection of these two inequalities, and now we just need to turn this into interval notation. Remember, with interval notation, whenever we have an or equal to, we use a bracket. So we'll have a bracket, then 1, comma, and then whenever we have a not equal to, just strictly less than or greater than, we have a parenthesis. So 1, 3, and then parenthesis around the 3. So there is our intersection using interval notation. But actually, we can do a bit more still. This is just the interval that results when we take the intersection of these two intervals. But we can actually write the statement that the intersection of these two intervals is that interval using interval notation. So why don't we go ahead and translate these two inequalities to intervals first of all. So x is greater than or equal to 1. What interval is that? Well, we're starting at 1, and that's an or equal to, so use a bracket. So it'll be a bracket, 1, comma, and then continuing all the way to positive infinity, and infinities always get a parenthesis. And then on the other hand, there's x is less than 3, so we're going all the way from negative infinity up to 3, but not including 3, so 3 gets a parenthesis. And now we can write that this interval, 1, infinity, when we intersect it with the other interval, this symbol just means intersection, so now we'll write the other interval, negative infinity, 3, the result is that we get the interval bracket 1, 3 parenthesis. So there we go. Using the intersection symbol here, we can write the full statement that the intersection of these two intervals is this resulting interval. Alright, next question. Write an inequality that corresponds to the set parenthesis -1 infinity and parenthesis intersect bracket 2 infinity parenthesis. So these are two intervals that are being intersected, and we want to find the inequality that corresponds to the result of that operation. Why don't we start by drawing each of these intervals on the number line? We can start off with this one here. Alright, so that one starts at -1. So we'll put a circle there, but we won't fill that in because it's a parenthesis. That means it can't take on the value of -1. It only starts at -1. Okay? And then it proceeds onward to positive infinity. So let's make it do that. Let's draw the graph onwards to positive infinity here. Alright. Now let's graph the other interval. This other interval starts at 2. So let's put a circle at 2, and we'll fill in this circle because it has a bracket, which means it can take on the value of 2. Likewise, this goes to positive infinity to the right, so we'll draw that in. Great, so we've got the two intervals drawn, and now it's just time to find their intersection. That's what that symbol says to do. It says to find the intersection, which just means, of course, where the intervals overlap on the graph. So we're looking for what parts of the graph have both red and blue. Well, it's this part right over here. Everything from here onwards that way. So why don't we go ahead and redraw this in green. We're starting at 2, and that gets a closed in circle because both blue and red are there, and then we go over this way. So translating that back into interval notation, we're starting at 2, and that includes 2, so have a bracket 2, and then going all the way to positive infinity. So bracket 2, infinity, infinity always gets a parenthesis. And we can turn that back into an inequality. That's just saying that x is greater than or equal to 2. Now, one important thing to point out in this example is that the result here turned out to be actually one of the intervals that we started with in our intersection. So that's a perfectly fine thing that can happen when you're intersecting two intervals. Maybe the result will be one of the intervals that you intersected in the first place, or maybe it might not. You shouldn't be too surprised either way. Alright, here's a final question. So given the inequalities x is greater than or equal to 1 and x is less than or equal to 0, express their intersection using interval notation. Alright, so this is pretty similar to the first problem that we started with, so let's just run through it in the same way. We'll start by graphing both of these inequalities on the number line, and then we'll find where they overlap. So x is greater than or equal to 1, that starts at 1, of course, and then it goes greater than 1, so it goes to the right this way. So let's go ahead and draw that in, and we can also label that with the interval. So in interval notation, that's starting at 1, including 1, so that gets a bracket, and going to infinity. So infinity gets a parenthesis. Now the other inequality, x is less than or equal to 0, starts at 0, so put a circle at 0, fill that in, and that goes to the left of 0, because everything less than 0, towards the negative. So it's going towards negative infinity. And then when we turn that into interval notation, we have it's going from negative infinity all the way to 0, and then 0, since that's a closed circle, that gets a bracket. Okay, so now let's find the intersection. Where do these two intervals overlap? Well, we have to look for red and blue together on the number line, but actually it doesn't look like there's any red and blue together. It looks like they're totally separate. It looks like there is no overlap. Alright, so how do we write this statement of intersection then? We state that this interval, negative infinity, 0, that intersection with the other interval, 1, infinity, what do we write at the end? Do we just leave it blank? Well, there's a more satisfactory way to address this situation than to leave it blank. And the more satisfactory way is to interpret, instead of thinking about there being no answer, think about it as though the set of values where they overlap is empty. So now the overlap is still a set, just like these two intervals, they're still sets, but the overlap is just a set which is empty, a set which doesn't contain any elements. It's like an interval that has no length. And there's a special symbol for the empty set, which is written like this. So we call that the empty set. And that's what we have. There's our statement of intersection. The intersection of these two intervals is the empty set because they don't overlap at all. Great, so now we know how to find intersections of intervals and write intersections using interval notation. In the future, we'll learn how to apply the idea of intersection to solve simultaneous linear equations.